Hello students, in this video we are going to discuss Cbse class 10 maths chapter 10 circles. We are going to go through the second concept and then we are also going to look through the questions given in exercise 10.1. So the second concept in this chapter is going to be the theorem 10.1. So first we'll note the theorem 10.1. Let's look into the statement. The tangent at any point of a circle is perpendicular to the radius through the point of contact. We already learned what is the meaning of point of contact and what is the meaning of a tangent in the previous video. If any of you are having doubts in that, please get back to the previous video so that it will be easy for you. So the tangent at any point of a circle. So we are drawing a tangent. Okay, they are telling that it is perpendicular to the radius through that point of contact. So a tangent, it will touch the circle at a point and that point is called as the point of contact, which is P here. Okay, so this the radius drawn from the center to the point P will always be perpendicular, okay, to the tangent. That is the theorem. So for that we have a small proof. I just quickly go through it. So we have a circle and we have a tangent. XY is the tangent. So we have to prove that OP is perpendicular to XY. We need to prove OP is perpendicular to XY. So we are taking another point Q that is going to be somewhere else other than the point P, and we are seeing that it is going to be a point outside the circle, because if you have the point P inside the circle, you have the point P inside the circle point Q, then you will see that when you join it will become a secant. Okay, it will become a secant, so it will not be a tangent. So we are going to take a line which will be OQ, and OQ, when we are looking at OQ, we are able to see that OQ is longer. OQ is longer than the radius OP. OQ is greater than OP. So in that cases, we are able to see that since this happens for every point, so on XY, whichever point you take that is outside a circle, we'll be able to see that OP is the shortest of all the distances. OP is the shortest, and hence we are able to see that the angle made by this with the tangent is going to be 90 degree, because it is the shortest. If it is going to be slightly longer also, the angle will not be equal to 90 degree. So thus they have proved the theorem 10.1. So let's look into the exercise questions, children. What's the first question? How many tangents can a circle have? So how many tangents can a circle have? You know that a circle can have infinite number of tangents, because if you have a circle, you have infinite number of points. So at every point in the circle, you can see that you have one point of contact. So everywhere, at every point of contact, you can draw one tangent. So the answer is a circle can have infinite number of tangents. So next we have few fill in the blanks. So what is the first question? A tangent to a circle intersects in dash point. Okay, so how many points it will intersect? The next one is a line intersecting a circle in 2 points. It is called as what? So what will be the first one? A tangent. A tangent can intersect to a circle only in 1 point. What's the next one? A line intersecting a circle in 2 points. So I already explained in the previous video that 1 point, it means tangent. If there are 2 points, then it is called as a secant. And a circle can have dash parallel tangents at the most. For example, if you are going to draw a circle, you need to get parallel tangents. You can see that here if you have another tangent which you are drawing here can be parallel. Okay, or if you are drawing here, only this can be parallel. So if I'm going to take, I'll take this and this, or I'll take this and this. So how many parallel tangents? Only 2. So I'm going to take these two, it will be 2. These two also, it will be 2. So the answer here will be 2. What's the last one? The common point of a tangent to a circle and the circle is called point of contact. So here the answer is going to be point of contact. That is the name of the common point. If you still have doubts in these concepts, remember children, we've already discussed these in the previous video. So we'll again discuss the fill in the blanks quickly. A tangent to a circle intersection one point. A line intersecting a circle in 2 points is called as a secant. The circle can have two parallel tangents at the most. The common point of a tangent to a circle is called point of contact. The third question, a tangent PQ. So you have a tangent PQ here. Okay. So this tangent PQ at a point P of a circle. So we have a circle. We have to draw this diagram, children. This diagram is not given in the question. Okay. Of a circle of radius. So they are giving a tangent PQ at a point P of the circle. So P is the point of contact here. So this is the point of contact. The radius of the circle is going to be 5 centimeter. It meets a line through the center O at a point Q. Q means what? It is the point on the tangent. Okay. So that OQ is 12 centimeter. So thus we have OQ. And they are asking us to find out the length of this tangent PQ. So look at it carefully, children. We've learned in the theorem that the radius drawn through the point of contact will always be perpendicular, that is 90 degree. So here you have right angle triangle and you can go with the Pythagoras theorem. So I'll just do it. It will be OQ square is equal to OP square plus PQ square. So what is PQ square? PQ square will be OQ square minus OP square. So what is OQ? OQ is 12. So 12 square minus 5 square. So it will be 144 minus 25, which will be 119. So PQ square is 119. So PQ will be square root of 119. Okay, so the square root, children, just make a change. So the answer is going to be option D. Okay, the answer is going to be option D. So we have one last question. The last question is draw a circle and two lines parallel to a given line. So you have to consider a given line such that one is a tangent, another is a secant to the circle. So now we have to consider a line. Okay, if we are going to take a circle, we can consider a line inside the circle or we can consider a line outside the circle. So however we are going to consider, we'll have two cases. So if we're going to consider a line inside, we have to draw a tangent and a secant. Okay, this itself can also be a secant when you're going to extend it, or you can draw a secant like this and you can draw a tangent, but the condition is we'll have to draw two parallel lines such that one will be a secant and another one will be a tangent. Or if I'm going to take this line, okay, I'm going to take this line, then it's some given line somewhere else. So you can draw this as the tangent and this as the secant. So that's what I've given here, children. You can look into these diagrams. So in this diagram, we are considering this AB to be the given line. So CD will be the tangent and EF will be the, so this will be the tangent line and this will be the secant line, or it can be like this. So here this is the given line. So this is the secant and this is going to be the tangent. Is it clear, children? So with this we are completing the first exercise. Since the sums are all very small, I just completed the entire exercise in one video, children. We have also discussed the theorem 10.1. Hope you understood this. We'll go through the concepts related to the next exercise before we start with the examples and the exercise questions. Hope you understood this, children. If you have any doubts, please get back to the previous video where I have explained the concepts clearly. See you again in the next video of the next concept, children. Thank you, children.